All right, we're going to have a video lecture and we're going to do example 5 on page 89 of our textbook. We're going to solve this system of linear equations using Gauss-Jordan elimination and matrices. We're going to show all of the row operations. Now, I've written the 3 different kinds of row operations that we may use and their notation. So the first one, row I, can be switched with row J, and that's what that double arrow means. Number 2, a constant times row I can replace row I. And then number 3, row I plus a constant times row J can replace row I. Notice that the row you want to replace comes first. That's the row that you will replace. And this row, row J, is some other row that we're going to multiply a number by. All right, so I'm going to go to a blank page, and I'm going to put this example 5 at the top. And let's go ahead and get started on this example. I'm going to first start off by writing my matrix. 3, -2, 8, 9, -2, 2, 1, 3. 1, 2, -3, 8. Now we want to follow some steps, and that is the very first thing we want to do is get a 1 in the upper left-hand corner. And remember, our goal is to try to get this into the following form so that we can easily read the answer from the result. And the order in which I wrote those columns is the order that we're going to do. We're going to get the 1 in the upper left-hand corner and then complete its column. We're going to call that clearing a column. We're going to get a 1, well, down 1, over 1, get a 1 in the second row, second column, if possible, and then clear that column. And then finally, we'll get a 1 at the bottom of the third column, in this case. Down 1, over 1, get a 1, and then clear that column. That's the order in which we want to accomplish this. So that first thing, we need to get that 3, we need it to be a 1. Now there's a lot of possible ways of doing that. One way would be to take 1/3 times row 1 and replace row 1. That would work. The only problem is we would get -2/3 and 8/3. We'd get fractions very early. So we may want to hold off on that and try something else. Another possibility would be to switch row 1 and row 2, or excuse me, row 3, because row 3 has a 1, and it starts with a 1. And that certainly would work. It would be a very good idea. But I also want to show another sort of a clever idea, and that is I could take row 1 and add row 2. And replace row 1. I'm going to write clever down here at the bottom. And the reason why that's clever is that 3 and -2, if I add those, I'm going to get 1. In addition, if I look at -2 plus 2 in the second area, that would give me a 0 in the second entry. And anytime I can get zeros is a great thing. So I'm going to use this as my first row operation. So if we wanted to write down row 1 and then row 2 and show our work, 3, -2, 8, 9, -2, 2, 1, 3. And going down, we'd get 1, 0, 9, and 12. And that will be the new row 1. So I'm going to go over here. I'm going to write 1, 0, 9, 12 as my first row, and the other 2 rows stay the way they are. All right, so I have a new matrix, a new augmented matrix. I'm going to circle that upper 1 in the upper left-hand column. And just like we said before, now that we've got that 1, we want to clear that first column. In other words, we need to change the -2 and this 1 to be zeros. Now, here is the handy way to do that. We're going to leave row 1. We like the top row the way it is for the time being. We're going to change row 2. So I'm going to write that down, and we're going to change row 3. Now, in each case, we are going to multiply the pivot row, which is row 1. The pivot row is the row that has the circled number in it, the circled 1, the leading 1 in it. And the number that we're going to put here in each of these blanks is going to be the opposite of the number that we want to change to 0. So in this second row, we want to change a -2 to a 0, so I'm going to put a +2 here. And in the third row, we want to change this 1 to a 0, so I'm going to put a -1 there. And those are the 2 row operations that I'm going to do to change row 2 and to change row 3. All right, so let's write a little in words. The row you want to change plus a number times the pivot row. And n is the opposite of the number you change to 0. All right? That's how we're going to do it. All right, so let's slide this up a little bit. I'm going to copy the first row, 1, 0, 9, 12. It does not change. And we're going to do row 2 and 2 row 1. We're going to add those together. So row 2 is -2, 2, 1, 3. 2 times row 1 is 2, 0, 18, 24. And going down, we're going to get 0, 2, 19, 27. And that goes in for row 2. So 0, 2, 19, 27. All right, in the third row, we're going to write down row 3, which is 1, 2, -3, 8. And we're going to write down the negative of row 1. The negative of row 1. That would be -1, 0, -9, -12. So we change the signs and add. So we'll get 0, 2, -12, -4. And that's going to go for row 3. So 0, 2, -12, -4. We've got our second matrix. Notice we have cleared the first column. So now we move down 1 over 1 from this 1, and we're going to want to get a 1 where that 2 is that I've circled. Now, we've got a couple possibilities. One possibility would be to multiply row 2 by half. But I get 19 halves and 27 halves there. And I'm noticing that I could definitely multiply the third row by a half and then switch rows. So I think that's what I'm going to do. I'm going to switch row 2 and row 3. And let's write that first. So 1, 0, 9, 12, 0, 2, -12, -4, 0, 2, 19, 27. And then I'm going to take half of row 2, this new row 2, and replace row 2. So 1, 0, 9, 12, 0, 1, -6, -2, 0, 2, 19, 27. All right. So look at what we've got now. We're still working on the second column. We've got this to be a 1 now. We've got this to be a 0. The next thing we need to do is to change this 2 to a 0. So if we use our rule says we're going to change row 3 and we're going to add a multiple of row 2. Row 2 has the circled 1 in it. The 2 is what we're changing to a 0, so we're going to multiply by negative 2. So let's do that. Let's write down row 3, which is 0, 2, 19, 27. And let's write down negative 2, row 2. 0, negative 2, 12, and 4. Add going down. We've got 0, 0, let's see, 20, 31, and 31. And this will go in the place of row 3. We always replace the first row that we wrote down. All right, so let's write that down next. We're keeping row 1, and we're keeping row 2. And we're changing row 3 to 0, 0, 31, 31. Nice. All right, so we have cleared column 1. It's a unit column. We've cleared column 2. It's a unit column. Our 1s are going down and to the right. We go down 1, over 1. Next thing, we're going to circle that 31, that first 31, and we need it to be a 1. And again, anytime you're trying to get a 1, one possibility is to take the number that you want to be a 1 and divide through by that. So I'm going to take row 3, and I'm going to multiply by 1 over 31. I think we can do that. So we've got 1, 0, 9, 12, 0, 1, negative 6, negative 2. Divide by 31, I get 0, 0, 1, 1. All right, we're on the home stretch now. We're still working on the third column. We've got the 1. Now what we need to do is change row 1 and row 2. We've got to get this 9 to be a 0 and the negative 6 to be a 0. In both cases, we're going to add a multiple of the pivot row, and that's the row that has the circled 1. That's row 3. So this first one will replace row 1. The second one will replace row 2. This is a 9 here, so I'll write negative 9 here. This is negative 6, so I'll write positive 6 right here. So let's go over and show our work. Row 1, we know that's 1, 0, 9, 12. And then negative 9, row 3 is 0, 0, negative 9, negative 9. 1, 0, 0, 3. All right, so let's see here. We are replacing row 1 with 1, 0, 0, 3. We know the third row is fine. 0, 0, 1, 1. Now we've got to change row 2. So we're going to write down row 2, 0, 1, negative 6, negative 2, and 6, row 3. So multiply row 3 by 6. 0, 0, 6, 6. We add going down. 0, 1, 0, 4. So that goes in row 2. All right, so we've cleared the first column. We've cleared the second column. We've cleared the third column. We've got our 1s going down and to the right. This is in row reduced form. And so this is the X, this is the Y, this is the Z. X equals 3, Y equals 4, Z equals 1. And we're going to write that as an ordered triple, 3, 4, 1. And that is our solution to this problem.